All right, Harmony Science Academy Algebra 2. We're going to look at inverses of squares, okay, or square functions, which are square roots. We've been looking at them. But now we're going to pay attention to their relationship, okay? The opposite of a square is a square root. So, we're going to look at graphs of these, okay? Focusing on their inverse relationship. And then we'll move forward, okay? So, let's just cover the basics. So this table is going to demonstrate a square function, okay? So when we're asked, right, hey, what is x squared? It means a number times itself equals what, right? So 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, okay? In this case, we're asking the reverse, okay? So it would be, what two numbers multiply to give 0? Well, 0 and 0. Okay. What two numbers multiply to give you 1? 1 and 1. Okay. What two numbers multiply to give you 4? 2 times 2. And what two numbers multiply to give you 9? Okay. Now, some of you guys are already thinking, and you realize that technically there is, we could say negative 0, but 0 and negative 0 are the same thing. Okay. But here, Mister, you asked two numbers that multiply to give you 1. We have negative 1 times negative 1. Same thing with negative 2 times negative 2 would give us 4. And negative 3 times negative 3 gives us 9. Okay? So that's why a lot of times you're going to see that the answer, right, when you try and take the inverse, it's actually going to be like this. Y equals plus or minus, okay? Now you're going to see things like this. So you'll come back to this information and you'll understand, okay, that makes sense. Now it's going to take some time to think about it, but at least you won't be completely lost, okay? All right. Now let's go ahead and plot this square function values. Okay, so 0, 0, 1, 1, right, 1, 1. And let's go to 2, 4. And I guess that's 9. Okay. So the same thing as we already know, negative 1 squared, negative 3. All right. So that's why we get these parabolas, because of that property, okay, where you take a value and you square it, okay? Once you map it onto a graph, you get your parabola. Now pay attention to what happens. Now, of course, this is a function. It passes the vertical line test. Now, if we were to do the same thing here, okay, let's get black. Okay, we'd go 0, 0. We'd have 1, 1. We'd have 4, 2. And we'd have 9, 3. Okay. We'd also have what? 1, negative 1, 4, and negative 2. And we go to 9 and negative 3. Okay, so we would get what some of you guys would have thought, what everyone should be realizing, okay, that makes sense. Okay. Now, in this case, notice that what I had to do is I had to include these values, right, these positive values, and their negative versions down here. Okay. So we have to be aware of that, so that had I just grabbed this, put in the calculator, it'd be incorrect, right? This is a parabola, so is this one. Okay. Now the other thing to keep in mind is that this is not, first of all, this does not pass the vertical line test, so this is not a function. Okay. So be careful. A lot of times it's safer to call these relations, okay, until you can establish that they are functions. Okay. The other thing is, let's try this guy. All right. In terms of inverse, okay, relationship graphically speaking, you'll notice that there's a reflection. Okay, so this portion reflects right here off of what they call this line y equals x. Okay, so that's very important, and then this portion would reflect off of this line as well over here. Okay, so again, you might have to watch this again over and over until it really you get comfortable with it. Okay, so those are some properties that you should be aware of. So I think we can move on here. Okay, now pay attention to this scenario. So if I'm asked to take the inverse of x squared, okay, it's not going to be a function. We just discussed that briefly here in a second. Why? Because you're going to get this kind of mapping, right? And it does not pass the vertical line test. So it's not a function. So anytime that you're going from x squared, okay, and inverting that to get some kind of square root, that's where you have to be careful and start considering restrictions on the domain and things of that nature. Okay. Now in this case, the inverse of the square root of x, yes, it is a function because why? As we discussed earlier, this would simply be that. Okay. So when it comes to inverting a square root, it's a lot of the times going to be a lot easier for you to express yourself. When you're taking the inverse of an x squared, there's considerations as you are graphing and communicating what the square root is. Okay, so again, there's a lot of details here. They're very manageable. You just got to kind of toy with the calculator and toy with your math. Okay, but anyways, we've done inverses before, so here are the steps. Okay, we'll go ahead and pause there. And ultimately what we care about is getting to CBA type material. Okay, so we're going to look at a square root function. We're going to invert that, and we're going to look at a square function and invert that and see how that goes. Specifically, for each function, find the inverse and the domain and range of that function and the inverse. Okay, and then determine if it's a function. All right, so for number 20, let's go ahead and set it up. So we have this. All you guys are experts, right? Y equals. We flip, right? Or switch x and y. And we solve. Okay, how do you get rid of a square root? You square both sides. And how do we continue? We subtract 3. And we now multiply by a negative. I have to go fast to shorten this video, okay? So we're going to have y equals negative x squared plus 3. Okay? So now that I have the function and its inverse, okay, and this down here isn't necessarily an inverse function, okay, so we can call it an inverse relation just to be safe. Okay, now that we have the function and its inverse, we can go ahead and come in here and graph it. Okay, so what they want us to do, excuse me, is they want us to, whoops, alright, describe the domain and range for both of them. Okay, so let's go ahead and do that. Now, I think for all of us, the best thing to do is graph these so we can see what we're doing. Okay, so in terms of domain for this given function, okay, which is going to be f1, we can see that what the domain goes from x is less than equal to 3. The range is greater than or equal to 0. The domain for the inverse, we have to be careful. We need this mapped. This needs to be mapped, right? And if we draw that line y equals x, technically this portion should be gone. Okay. So what we're going to need to say is here. Okay. Now don't feel lost, because obviously this parabola isn't mirrored by this half of a parabola, right? So I do have to chop it down. And in this process, what I'm going to do here, okay, I'm going to come in here and I'm going to say that my x's cannot be negative. Okay, so notice that by looking at the graph, I realized, oh yeah, I definitely got to chop this part off. Okay, so that's going to leave us with x greater than or equal to 0. So that way, as soon as I restrict the domain, that gets chopped off. Okay. Alright, so now that I'm looking at this, the domain here is what? X greater than or equal to 0, and the range is what? Y is less than or equal to 3. Okay. Alright, and before we leave, the main thing for you guys is that this inversion process is the most important. Okay, so you guys have done inverses, you're going to be fine. It's all this domain and range stuff that is going to take you some time here for this practice to think about, but don't worry for as far as the CBA, don't stress over that part, okay? Your ability to invert is going to be the most important thing, okay? But again, for the practice, take the valuable time to think about this, look at the graphs, and think throughout this process. It'll just boost your confidence, okay? All right, so let's go ahead and jump to 22. All right. So same thing, let's go ahead and start off with, let's see here, y equals, and we're going to switch. Okay, let's start solving. And let's take the square root of both sides. Okay, I guess here I'll do it for some of you guys. You should already have it in your head. Hey, the opposite of a square is a square root. Okay, so that means this cancels and you're left with y equals. Okay, now, and let's wrap it up with the f inverse notation. Again, we can't call it an inverse function, but we can safely call it an inverse relation for now. Okay, so this is what we have. Now if we go to the calculator, okay, we get something like this. Now notice something, okay? We've got this x squared over 2 here, okay, which is a parabola, which we love, right? Real simple. Now this part, square root of 2x, is up here, right? But I'm actually not getting this whole reflection. I'm only getting a piece. Why? Because remember that negative, right? So that's when I express myself. Okay, how do I know that I'm in trouble? Because the reflection of this should not just be this portion, it should be a parabola, okay, horizontal parabola. So that's why I would include that here now. Okay, all right, now let's go ahead and wrap it up here. So the domain and range for the original function. Okay, let's go and start there. X squared over 2. So we see that it's x. All real numbers, okay? X is an element of all real numbers, okay? Left and right. The range, y is greater than or equal to 0. Now, not this portion, but this f inverse, and we can actually squeeze this in here, okay? But notice that mathematically, you've got to understand what's happening for you to add the plus minus, okay? If you forgot, look at the beginning of the video. Anyways, so we're now here, we're looking at this horizontal parabola, and the domain, we've got x's greater than or equal to 0, and the range is all real numbers. Why? Because they go up and they go down as far as you can. Okay. Now again, if we run the tests, the vertical line test, this is not a function. Okay. So we can say that. Where is it? We can do something like that. Okay. Not a function. And if you go back to 20, right, determine if the inverse was a function. In that case, whoops. Okay, when it comes to 20, I'm pretty sure I forgot to include that step, f of x. We can absolutely say that it is a function. So take a look at your notes and confirm that as well. All right, guys, appreciate your time. Catch you in class.